Now, the second most commonly used scale, at least here in the States, would be your engineering scale. And you're going to find this one used a lot when you're trying to do precision measurement for like gears and so forth. And it's usually pretty simple for students to get and understand because it's based on tenths. I have kind of joking because in the last 10 to 12 years I've noticed a real change in when I'm teaching how to read scales. It's changed. It used to be that the architect scale was the easiest one for my students to understand because they'd been measuring in feet and inches forever, and they understood that there's 12 inches at a foot. They used all those measurements. Well, we do know that about a decade or so ago there was the big push to start switching everything to metric and everything based on the tens for more precision measurements. Okay, we understand that. Well, I've noticed in the classroom over these couple of years that this seems to be a little easier for students to understand. So, the thing about your engineering scale is it based on tens. So, like for the example here, it could be feet, it could be inches. Those are the different measurements. So, it's kind of like the hybrid between the metric and the architect. You can look at it that way. So, this could be 1 foot, 1 inch, 1 whatever. So it just kind of depends on what the requirement is. It'll tell you what's your scale. So if unless it tells you specifically to list it in feet or inches, you're just going to draw the measurement for it. The way it works is you've got your 10 is your full, 20 will be your half, so the 20 and a half, 30 is a third, 40 is a fourth, fifth, and so forth. And now again, it can be feet and inches. You just kind of have to pay attention to what the requirement and what the scale says and what they're telling you you're using. You will also very often see the engineering scale used when you're doing civil engineering. Because in civil engineering, we can say on this 10 scale that that 10 is actually equal to 10 feet. Or we can say it's equal to 100 feet. So you can represent different things using the scale. You just have to make sure that you note it at the bottom that this is equal to 10 feet, 100 feet, so forth. So let's practice actually finding some measurements here. I'm going to use something really simple, just the A to B, and we're going to practice finding the 10, the 20, so forth on it. All right. So let's get our engineering scale. And how the heck do we know what that scale is compared to everything else? All right, well, I gave you the hint. The 10s, 20s, 30s, 40s, correct? So let's pull up mine. Somewhere, in some way, shape, or form, on that scale, you'll find the word engineer. So on mine, it's on the 30. So in this particular case, this would be like the third scale of an inch or a foot, depending on what increment. So 1, 2, 3, 4th. Red, come on, pencil, get in here a little better focus. There we go. See, this is a little better. 1, 2, 3, 4, so forth. So let's actually practice finding this measurement on the different scales. So let's do it on the 10, the 20, and the 30. We're not going to do all of them, but this will get you enough of a principle that you'll understand. So, divider, measurement. So I've got my divider on the measurement. Flip my scale around until I find the 10. There's our 10. We're just going to say this one's just plain old inches. Put it on the 0. Put one on the 0 and the other end over here. And I'm looking at it, and as I notice and I look at it, it is 4.2. On the 10, 4.2. And then that would either be feet, inches, so forth, just depending on what I need it to be. So if I go to the 20, lay it on there, and I'm looking at the scale and I realize it's 8. It's 8.4. And yes, if you're smart, you can notice that there is a bit of a pattern going on here. Okay, let's go over to the 30. Put it on the 0. So I'm looking at this, and it's 12.5, 0.6. And that's it. That's pretty straightforward. As most students I've found over the years, that the engineering scale is actually their favorite one to use. It's very straightforward. It's kind of like the hybrid between the two. Makes sense to them because it's based on tens. It makes it very simple. They just get in, they start measuring everything. So I find a lot of students really like using the engineering scale. Doesn't really matter to me what scale you're using in the class as long as you note it and you use the scale that it requires. So if you're given an assignment that says you have to use a scale, make sure you use that correct scale. All right, let's do that same thing here. Let's find the diameter of this using the engineering scale. So I place this right on here and I get my measurements, and let's go ahead and do it on the 60. place it here, and I'll look at it and I realize, okay, come on, get into focus. Okay, try coming in it from this direction, maybe it'll work a little better. Okay. So 0, and it's just past the 6, so I would know that's 6, that's 7, that's 8. So that gives me an idea. So I'm looking at here, 6, 7, 8. So I know it's 10. So that's 2, 4, 6, 8, 10. Okay. Put it on the 0. So I'm looking at 6.4. So I have a diameter of 6.4. Diameter 6.4. Now, if I needed to get the radius, because that is sometimes a little hard to show you here real quick because I didn't show you in the last video. Let's see if I need to get the radius of here. I'm going to put 1 in here, 1 there. So it's from that center point to the edge. If I was getting the radius of this one, it'd be from the midpoint to here. Or move my divider back in to there. So you're going from their center point out. Let's say this little one right here. I need to get the radius of that. So radius is simply half of it. I find it. And again, yes, you can lay this directly on here. Start at your 0, find your measurement, get it on there. Just make sure you're keeping it lined up nice and straight. Or you can use the divider like I've been and use it finding that way. It doesn't matter. Both methods are acceptable. I'm just trying to use a divider to make it a little easier for you to view as I tilt it up. All right, good luck. If you have any problems understanding how to use the engineering scale, please see me in lab.